Hello, my name is William, and it is currently Thursday, March 16th at about 9:30 p.m. I'm going to be presenting my project for Schematics, which is a scrolling LED kit. Let's go and take a look. This circuit is designed to display a message across these LED matrices that will scroll until the full message has been displayed, restarting immediately once the last character has appeared. There are 6 major regions in this circuit: the voltage regulators, the microcontroller, the parallel transistors, the push buttons, the shift registers, and the LED matrices. At the plug here, a 12-volt DC signal is input into the circuit. That 12-volt signal is fed into these 2 voltage dividers here and reduced to 2 volts at the top voltage divider and 5 volts at the bottom voltage divider. The 2-volt signal is used to power the shift registers located here, and the 5-volt signal is used to power the microcontroller here. In order for the LEDs to turn on, there are a few things that need to transpire. For reference, the microcontroller is connected to the cathodes of the LEDs, and the shift registers are connected to the anodes. When an LED needs to be turned on, the microcontroller will activate the corresponding transistor or transistors by supplying a current to the base terminal, allowing for a connection between the collector and emitter terminals. This provides that row with a path to ground. The shift register will provide current to the corresponding column when it receives the clock signal from the microcontroller, shifting that current to the next pin at the negative going transition of the clock pulse. With a combination of the microcontroller and shift registers, we have essentially created a matrix of switches. Now that we have a broad overview of how the circuit works, let's focus on a few of the more crucial aspects. It would be impossible for the message to scroll if it weren't for the clock signal, which is generated inside the microcontroller. The 2-volt signal that is used to power the shift register is also fed into pin 3 of the microcontroller. That signal is used to create an 8-bit signal that is fed into a multiplexer that can either increase or decrease the clock frequency. That resulting frequency is output at pin 15 and fed into each of the shift registers at pin 8. Additionally, we have these 4 buttons here which are used for scrolling and text input. For scrolling, that can be used to manually scroll through the message, increase or decrease the scroll rate, and restart the message at any point. For text input, they can move the cursor left or right, increment or decrement characters, and insert or delete characters. Overall, the circuit itself is pretty straightforward when you have some rudimentary transistor knowledge and have taken digital fundamentals. The only complicated portion are the microcontroller, which has a 400-page datasheet, and the voltage regulators, which are trivial by comparison. So that glitching that you saw is due to the voltage coming from the shift registers not being sufficient enough to power the LEDs, or to toggle the LEDs, and causing multiple to trigger at once. So if the voltage is too low, you'll get a result like that. However, once you increase it to a sufficient voltage, it regulates itself. Now, I'm going to go ahead and let the circuit run for a short while for your viewing pleasure. I hope that you enjoyed the video. Take care and have a wonderful rest of your day.